This is Gerald Clark with Seventh Planet Broadcasting on March 7th, 2018. And I kind of thought that it might be a good idea to do a little bit of a supplement to the last episode since I had not coordinated to share any of the images or diagrams to help explain the theory. And I thought it'd only be fair to at least give that an attempt. I had a document prepared before the interview happened, which I was going to explain, but I did get permission from the author via my last guest to share this. That was Roland Michel Tremblay. Anyway, so I'm going to run through this kind of quickly just to mostly give everyone a chance to see some of these images. Let me grab my glasses. Okay. So, last time we basically introduced the final theory, which is a book by Mark McCutcheon. And you can see a picture of the book here. The ultimate understanding, the theory of everything, sought by Aristotle, Newton, Einstein, Hawking, and many others, is expected to bring clarity and understanding that is unknown today via the overlooked principle in nature. Anyway, so the final theory shows why this is occurring, exposing centuries of well-intentioned but misguided scientific thought, and showing that the various known forms of energy actually arise from a single unifying scientific principle that we have overlooked or misunderstood for centuries. For the first time, this new principle finally explains and unites gravity, light, electricity, magnetism, atomic structure, replacing many of today's theories with this single scientific principle. Okay, so the final theory overview, I'm going to do a quick overview for you here. This was published by Roland, so he told me I could share this with you. Okay, let's get started. A clear analysis of our belief in Newton's gravitational force, showing the many flaws in this belief. And by the way, that's what we did in the second gravity series, was the gravity pioneers, where we talked about Newton and Einstein. Okay, many of which are rarely, if ever, discussed. This in-depth analysis of Newton's ideas is only possible now from the powerful new perspective found in the final theory, which takes a giant step back from today's beliefs to provide the first true understanding of our universe. A deeper analysis of gravity showing where Newton's ideas came from, exposing their origin as educated guesswork combined with logically and physically flawed assumptions that crumble under serious scientific scrutiny. We also pointed out that there was a school in South India that had already published some of the precursors to the infinite series used in calculus. It was part of the laws of motion that got borrowed as well. And these were published hundreds of years before the late 16th or the end of the 17th century when Newton was involved. A new geometric orbit equation is presented that follows from purely empirical observations, showing how Newton disguised it in terms of his gravitational force, giving the orbit equation known today an undue credibility to his theory of gravity. That's easily rebuffed. A big picture overview, rethinking the many observations currently attributed to Newton's gravitational force, such as falling objects, rainfall, belief in anti-gravity, shooting cannonballs, the weight of objects in our hands, etc. An analysis and critique of Einstein's very different general relativity explanation of gravity using warp space-time. So let's jump through a couple of these bullet points kind of quickly. Okay, a summary of the theory of gravity. A summary of gravity is given in the context of one of the four fundamental forces in nature: gravity, electromagnetism, strong nuclear force, and weak nuclear force, plus a couple others that I'm going to throw in. But it covers those four basic ones. Okay, so let's talk about some of the troubles with gravity going all the way back. Gravity has many problems in today's science. The convenient model of an attracting force matches appearance rather well, but where does this mysterious force come from? Why does it attract? Why not repel? Where is its power source? Arbitrary forces can't simply arise and affect us in our daily lives without explanation. Yet this is precisely what today's science says about gravity. The excuse offered by scientists today is that gravity does no work at all, despite holding us on the ground, constraining planets in orbit and orchestrating all the dynamics in the heavens. An equation known as the work equation, developed over a century ago to quantify the work done in a moving object, has been seriously distorted and misapplied in a failed attempt to justify Newton's gravitational force. And we go on and on, rebuffing in the first chapter of Mark's book, Newton and Einstein. So let me just do a couple of these. This work formula has been systematically misapplied over the years to ensure it gives a zero result in a gravitational situation so that scientists can claim that gravity does no work throughout the universe and needs no power source, rather than admitting that gravity is a mystery to them. And for those of you that don't know what the work formula is, I think it's force equals, x equals force times distance if you're just in the x direction in a line. So the demonstration they give is if you're pushing against a rock and the rock's not moving, the work function indicates that change in x is 0, so there's no work. But the reality is you or whatever is pushing against it until it actually moves it is doing a massive amount of work. That's what he's explaining here. Newtonian gravity also violates the speed of light, a current law of physics, since it has no speed limit at all. Einstein even felt the need to completely rethink the nature of gravity, his warped space-time concept, while today's scientists are still looking for answers such as quantum gravity and superstrings, while desperately looking for their proof in their theories and hunt for graviton particles and gravity waves. Gravity is one of the most familiar experiences known to man, yet still one of the greatest mysteries in science. Okay, and by the way, I'm going to cover a little bit about the detection of gravity waves when we get to the LIGO project. The origin of Newton's gravitational force. Before we can solidly discuss what gravity is, we truly need to understand the origin of our current belief in Newton's gravitational force. This discussion shows that Newton invented his force using a flawed analogy of a rock swung by a string and perpetuated the air by creating an entire system of concepts and equations based on his invented force. This is the tetherball theory of gravity that I was telling you about. Does the evidence support a gravitational force? The fact that objects are held forcibly on the ground or accelerate downward when dropped does not prove Newton's gravitational force. These are undeniable effects. Okay. And by the way, we mentioned in the last show that most of these effects can be modeled just by observation without having any theory at all to come up with 9.8 meters per second squared. Okay. I could do it in my backyard in about 3 hours or less. These are undeniable effects, a weight effect and a downward acceleration effect, which we experience, observe, and measure. But whose cause has been a mystery for millennia and remains so to this day in our current science. I want everybody to know that's a fact. Science does not know what gravity is. Okay? In fact, even our equations for falling objects and falling projectiles don't involve mass or Newton's gravitational force. They only model the downward acceleration effect complements of Galileo. In fact, it would be quite unprecedented feat for anyone known to accelerate all objects with equal ease regardless of mass, yet this is precisely the claim made in our science for Newton's gravitational force, since all objects fall at the same rate, irrespective of their mass. Now think about that. Bowling ball on a car fall at the same rate. So even though we use the equation weight equals mass times gravity, and force equals mgh, mass times gravity times the height, they always use the center of mass for the objects and don't take into account that these objects have maybe a different size and different edges relative to their center of mass. So it's kind of a kludge what they've done. Also, why can't we shield ourselves from Newton's gravitational force and levitate? Well, I think we can now, but it's not about shielding the force. We have shields for every other known force and field: electricity, electric fields, magnetic fields, light, radio waves, radioactivity. So why is Newton's force so special and different? Fact is, gravity is not a mysterious attracting force emanating from matter with no known power source, nor is it Einstein's warped space-time concept or any of the other increasingly bizarre theories in today's science. It is something else entirely, something much more sensible and much simpler to comprehend. And by the way, for those who have not been exposed to Newton and Einstein, the atomic expansion theory actually is easier to comprehend because you don't have to get rid of all these models that are blocking your understanding. What I want to show you next is a fundamental to the atomic expansion theory, which is the atomic expansion equation. Okay, and I'm not going to spend a massive amount of time on it, but I will kind of read through it and explain it for anybody who wants it explained. So basically, it comes out to 7.7 times 10 to the negative 7th per second. This is the expansion rate of the atom. Okay, it's interesting it doesn't have any units. I would have thought it would, like meters or inches or centimeters or microns or something. So what this, let's read this and then we'll go back and do this equation. The atomic expansion equation above calculates the changing distance d prime between two expanding objects of radius r1 and r2. So here's d prime, r1, r2. The top portion of the equation is the absolute decrease in the original distance d, okay, between two expanding objects as they take up more space, and the bottom portion is the further relative decrease or scaling down of this distance over time in comparison to ever expanding objects. Okay, so here's the denominator here he's talking about. Okay, and there's the x sub a, which is a constant here. Okay. The variable n is the number of seconds that have passed since the original distance was measured between the objects, and the value shown for x sub a is the same universal atomic expansion rate calculator, which never changes. By the way, that doesn't matter where you are in the galaxy, this applies. Okay. This is the equation for all falling objects and all objects floating in space as they effectively approach each other due to their mutual atomic expansion, an effect currently thought to be due to Newton's attractive gravitational force, which is not correct. Okay, so as you remember, we talked about the rate at which matter expands. It all happens at the same time, so you can't detect it. But there are a couple of thought experiments and actual physical experiments that can be done to show that this is more than likely, with high probability, the case. Okay. This new model of the atom, strong and weak nuclear forces and chemical bonds. We talked about this in the last show. Okay, so let's go through this just real quickly. According to Mark McCutcheon in expansion theory, the electrons bounce off the nucleus of the atom instead of orbiting it. The protons and neutrons are also made of expanding electrons, and they push against each other in their expansion due to x sub a. So the nucleus also constantly expands, explaining why the bouncing electrons are reaching higher every time, creating that constant small expansion of the atom at the edge. The atoms coming closer to each other glue together by exchanging bouncing electrons between their nuclei. This is how molecules are formed, the chemical bonds. This elucidates the strong nuclear force within the atom. There's no need for an invented nuclear force within the atom in order to keep the protons and neutrons together and prevent the nucleus from flying apart. It's easily understood with expansion theory that these particles are simply pushing against each other in their expansion. Okay, this is like a big beach ball and a little beach ball, but at the atomic level. A neutron is a less stable proton, and a neutron becomes a proton by simply losing one of its electrons, when the electrons within it are trying to find balance and become more stable. This describes the weak nuclear force. All this is very well explained in McCutcheon's book. Okay, the next topic is electromagnetism. I'm going to get a little drink here. Okay, I hope this is helping you guys illuminate some of this very hard and esoteric theory to wrap your head around. Being an electrical engineer, this one caught my attention. There are no more electric charges or positive and negative electrons or particles. McCutcheon has shown how the simple expansion of the electron can justify all observed phenomena in physics, including why we thought subatomic particles were charged. Electricity is simply expanding electrons inside the atomic realm, meaning they don't expand greatly outside the atomic realm, while pushing each other on wires. This is current flow. Magnetism is expanding electrons outside the atomic realm in a crossover effect, which expand greatly in clouds of electrons. Their movement is explained in the final theory as moving from locations with a surplus of electrons to other locations depleted of them in order for the electric current or system to reach a balance of electrons. Energy. Light and heat are clusters of electrons expanding greatly and freely outside of the atomic realm. They expand at the speed of light. Well, that depends on the medium. Everything is essential made of electrons, including all radiant energy phenomena. Energy, including light, is made of matter instead of photons, meaning light is made of clusters of different sizes of expanding electrons. So a photon is a group of electrons, what he's saying, defining the intensity. Okay. Radiant energy is still physical in nature. It's made of electrons. So an entity made of light or energy is still part of our physical reality, is still made of matter, because he considers an electron matter. Therefore, matter is responsible for energy in its motion, is what he's saying. And I touched on that a little bit with roll on in the last show. Here's a table showing some of today's energy euphemisms. Now, I hope I'm able to share this. I think I got this from Roland, but if I accidentally got this from Mark's digital book, I'll have to apologize to him, but I think it's worth looking at real quick. Okay, so here's the euphemism, today's term for gravitational energy, and the physical description in expansion theory. An effective attraction between objects due to their ongoing expansion as objects composed of continually expanding atoms. That's what they call gravitational energy. Strong nuclear force, the natural cohesion of protons and neutrons in the nucleus of an atom due to their tremendous ongoing subatomic expansion against each other. Electric charge, attracting or repelling forces caused by the crossover effect of externalized expanding subatomic particles acting between subatomic and atomic realms. Chemical bond, a manifestation of the crossover effect between subatomic and atomic realms occurring between individual atoms rather than overall objects. Magnetic energy, clouds of expanding electrons surrounding conductive objects attracting or repelling via the crossover effect between subatomic and atomic realms. Electromagnetic energy, bands or clusters of freely expanding electrons that continuously push on one another through space due to their ongoing inner subatomic expansion. Kinetic energy, the apparent absolute energy of motion possessed by objects, but which is actually only a purely relative motion between objects. Excuse me. I had the hardest time, actually, when I went back to review this theory with motion and orbits, I have to say, because when you visualize that, matter in space is floating and it's expanding, well, what does it do when it comes within some proximity of other matter of the same size, varying sizes, and you run through these little thought experiments to go, well, how does this work? So this is what this diagram set is about. Motion is entirely geometry based. The geometry of expansion and motion is relative. All orbits can be explained by this expansion. Excuse me. Here are two figures showing what happens when two expanding objects pass each other in straight lines in space and how it leads to a natural orbit effect. When you consider they're expanding proportionally with everything else. Now these ones are the same size. So the way this diagram works is, imagine this object is speeding past another one. And they don't tell you what the speed is, they're just telling you it's in motion. Now, if the assumption is that the speed does not exceed the expansion rate or is just slightly below it, then the objects will appear to be attracted to each other. This is the hard part to wrap your head around. So here's the concept on the left. So at point number 1, the object's a certain size. After a certain time, through the expansion theory, it's the size, the number 2, and then at time t3, it's this size, okay? And they're traveling along a line in this direction. Now, and like I said, they don't tell you how fast. So let's assume they're traveling at just the speed not to exit the orbit, okay, but just enough to be trapped into geosynchronous orbit, okay, where it looks like it's just falling and traveling forward at just the right balance where it stays equidistant and facing the other object, okay? So just keep that in mind. So in reality, on the right is the net result of this orbit effect. So it probably would have been better if we had kept it small like this so you could see it in its. Okay, so imagine now that this one and this one are this one and this one, and they got close enough and they're not traveling fast enough to go on and pass each other, but now this one's trying to, or this one is expanding toward this one's expanding toward this one, so you can see these distances got shorter. Here was the original distance, okay? If you just drew it straight down, it would be to the center. Well, if you really would just want to go from the edge to the edge, because the atomic expansion theory uses the edge of objects, not the center. Okay, well you can see right here they're even closer, and here they're even closer. Okay, so at this point they're very close, and what we're saying is that the atomic expansion rate, which accounts for the gravity of this one and the gravity of this one, are the same, and now they've essentially entered into an orbit, like a binary star system, around each other because they weren't traveling fast enough to keep going, like this picture. Okay, they were going just fast enough to get trapped. So this one is hard to wrap your head around, but if you can wrap your head around this, you can see that this is actually the same orbital path that a satellite flies, almost in a increasing arc, a helical arc, in order to stay within the gravitational boundary of not falling or not being impacted by the expanding Earth and still not flying away into deep space. So I hope that one helps you. Let me read this. Maybe he does a better job. The two objects are expanding in their straight line trajectories as seen on the left here. But this expansion is unseen by us because everything expands proportionally at the same rate, including our instruments of observation, our rulers, and ourselves. So what we see instead is what is on the right. The distance is shrinking between these expanding objects, creating the natural orbit effect of all moons and planets. Nothing could ever move in straight lines in the universe because of this. If you're wondering why the planets of the solar system are not being crushed by the expansion of the sun, if every 19 minutes the sun doubles in size, you need to understand that the planets' orbits are also expanding as the entire solar system is expanding. There is proof of this. One main proof is the Pioneer anomaly, which we talked about in the last show. This had to do with a satellite that was sent out beyond the solar system, supposedly, and at some point when it was no longer supposedly within the gravitational pull of the sun, as is modeled by Newton, it should have kept going and possibly being accelerated, but instead it slowed down, and they were trying to understand why. And the expansion theory explains that the solar system expansion is actually catching up with it because it's no longer being powered. I believe that's the theory. You can go back and listen to the last show and see what we said about that. All right, let's go on just a little bit here. There's a couple more pictures and I think we're done. Okay, so let's just talk to the pictures and then see if the reading is worth it. So this one clearly is the model of Newtonian gravity, where an apple falls, goes to the earth, and gravity's pulling down like this. Okay. Now it turns out that 9.8 meters per second force, instead of pulling down, actually is the expansion rate of this going up like this. Okay, like the elevator effect. So if you're in an elevator and it travels up, you're going to feel a force opposite pulling you down. Well, you're not going to, if that force is 9.8 meters per second squared, how are you going to tell the difference here to here, whether it's something pulling down or or this expansion up, and you feel the force pushing you down? Okay, that's the force you feel on your feet. Whereas in expansion theory, if all matter is expansion, let's call this one the big beach ball, and you are the little beach ball, and you're both inflating at the same rate. Well, since this beach ball is so much bigger than you, then pressure equals force times area, and the pressure you're going to feel on your feet is the expansion of this big beach ball blowing up, because yours is so small relative to it. It doesn't even count, and you can practically ignore it. Okay, so your expansion of you against this one is so minuscule that it can be ignored. So what you're feeling is the atomic expansion rate when you apply x sub a to basically the geometry of our Earth. You'll get 9.8 meters per second squared, just like you did over here. Okay, so I hope that helps you understand. And in this elevator experiment, last time Roland and I were discussing two balls suspended inside the elevator, or one on an elastic band holding, or a spring holding a weight, okay, while it's attached to the ceiling of this. So if this is accelerating up at 9.8 meters per second squared to simulate gravity, and if the force of gravity was truly pulling down, then you'd expect when the elastic was cut here at the top, that the force of this would continue to pull down, but instead these two collapse together as if they're floating in free space, okay, which is exactly what atomic expansion theory says they are doing while the Earth comes up to meet them. Okay, so it's kind of a little complicated to think that through, but you can stop the video and read through this and see if it doesn't help you understand that. And then the last piece that we brought up, we started dabbling with Mark's concept about how expansion theory suggests a varying density, and from most dense on the near side to least dense on the far side. That's actually what Rowland said about the moon, which is also in keeping one of the commonly proposed lunar creation scenarios. In this case, since the expansion of objects would proceed from their center of mass, there would be less expansion force on the near side and more on the far side due to the resulting off-center expansion. This suggests the double surface gravity on the far side to the average to the 1/4 gravity suggested by the moon size, a fact that would not affect either the moon's shape or any orbits about it, but could only be determined by direct surface contact. So this is where we were talking about the gravity on the near side of the moon being different on the far side of the moon. If you don't know that and have the equations to calculate it, your craft, if it was calculated to descend with a certain thruster force and it turns out gravity's stronger than that, you couldn't oppose that and you would crash, is what he was saying. So, or if it was not as much as you thought, you wouldn't be able to generate enough weight or enough possibly motion, I'm not sure, but you might actually miss being drawn in through the expansion rate if you didn't understand it. So anyway, I think that's all I want to say about the expansion theory today. I do encourage everybody to read the book. It was written for the lay populace by Mark McCutcheon, and Rowland, who I interviewed last time, has written many articles, probably the only one that's written articles on the book that you can find on that Facebook page, the final theory by Mark McCutcheon. Okay, so this has been Gerald Clark on March 7th, 2018. This is the Gravity Series Episode 3 supplement to help bring to life some of the things we talked about last time. And we'll talk to you guys in the next episode.